This conference will now be recorded.
Very good evening, students. Today we'll discuss few problems from IIT JEE previous year's paper, not advanced. This is mains. We'll discuss mains paper today on the topic current and electricity. Okay, so
This
today
conference will now be recorded.
we'll be discussing numerical problems on current and electricity chapter, and these problems are taken from IIT JEE previous year's paper. JEE main question we will discuss today. So the first question is saying the potential difference is applied across a wire 0.1 meter length. The drift speed of electron is given as 2.5 into 10 to the power minus 4 meter per second. If the electron density in the wire is 8 into 10 to the power 28 per meter cube, then you have to find out the resistivity of the material which is close to one of these four options. You have to find out the correct answer for this. See, first of all, let us write the informations given. So voltage difference, this is potential difference, 5 volt is given. Length of the wire is given. Drift speed of electron is given, 2.5 into 10 to the power minus 4 meter per second. Then number density of electron is given. This we can write Ne. Per meter cube. What you have to find out? You have to find out rho. So what is the rho? Rho is resistivity. This is, resistance is equal to rho L by A. Okay. Now you have to find out what is rho. Rho could be found out from R A by L. Right? Now what is this R? What is this R? We know current is equal to V by R. V is the potential difference. So R can be replaced by V by I. Okay. So we can write here it is V A by I L. Okay. But current is not given. Voltage anyway it is given. Area is also not given. So what we can do? We can, and what we have here instead of this current, we have the number density and we have the drift velocity. Look what we know about drift velocity. Like yeah. So how do we know the relation between current and drift velocity? We know current density is equal to N E, that is the number density of electron. E is the charge, and Vd, that is called drift velocity. Okay, and if you multiply area, then you get current. Okay, you get current. So I will write, see, in place of I will write N E Vd into A. Vd means drift velocity. Ne here number density. So let us write it here. V A. V is the potential difference that we know. Here, in place of I, will write NE into E, drift velocity Vd, and this is A, and L is also given, that is 0.1 meter. See this A, both will cancel each other, and other things are known. See, other things are known. This is 5 volt. Ne is given as 8 into 10 to the power 28 per meter cube. Electron, charge of electron is 1.6 into 10 to the power minus 19 coulomb. Drift velocity is given as 2.5 into 10 to the power minus 4, and one more I have to multiply in the denominator, that is 0.1 meter. Okay, I'll go to the next page and tell you what we are getting. So 5 into, I am writing again, so 5, see this is, sorry, so rho is 5 divided by 5 divided by, okay, I'll write the parameters. So I have 8 into 10 to the power 28, 2.5 into 10 to the power minus 4. E is the 1.6 into 10 to the power minus 19. NEVD into L 0.1. I hope I have written everything. Yes. So now look, we have to solve this. Resistivity actually will be ohm into meter unit. Okay. So if we remove this points, it will be here. Okay, some 100. So this gives 4. This goes with this. Okay, and again here, look, this is 0.1. I can multiply 110 over here and just remove point, so this will give you 5. All right, so here 25 divided by 16 into 10 to the power, look, this is 10 to the power 28 and this is minus 4, so 24 minus 19, that means 10 to the power minus 5 will be here. Okay, now this is 25, so 16 here, it will be so 1.56, around 1.6 into 10 to the power minus 5. Okay, so here the last option, that is the fourth option, D. Option D is correct over here. If you look here, this is the correct option in this case. Okay, we'll move on to the next problem. So next problem is interesting problem. This is a graphical problem. You see, suppose the drift velocity Vd in a material varied with the applied electric field E as Vd proportional to E. So Vd is proportional to, I'm sorry, this will be square root of E. According to the problem, it is not E. Vd, drift velocity, varied as square root of E. Then Vi, graph for the wire made of such a material, is best given by Vi graph, that means current voltage graph. So given this is this. Okay, Vd is directly proportional to square root of E. So we know we have to find out current voltage relationship. So we know I is equal to N, E and Vd. So NE anyway these are constant, and this is Vd is varying as this. So can I say this, that I is varying as square root of square root of Vd. This I can say anyway. All right. Now if I, okay, so this variation is Vi curve. Okay, so this Vd drift velocity is varying as square root of E, E and V voltage, they will be varying similarly. Okay, so it will be actually varying as capital V. This is the voltage. That means, you know, I can write okay, I'll just let me redo the things. So Vd is directly proportional to square root of E. Okay, so Vd is directly proportional to square root of E. This means it is directly proportional to the potential also, because E and V, they have the same dimension. Okay, almost the same dimension, because we know E is equal to V by D, right? V potential difference by distance. Okay, so that is so if this is root, then this can also be root over V. Okay, so drift velocity, we have found out that the drift velocity is directly proportional to square root of V, voltage potential difference also. Now I know I is equal to NE Vd. Then Vd is directly proportional to root over V. So I can write I is directly proportional to capital V. This V is actually the potential. So I can write it here, I square directly proportional to V. Okay, I square directly proportional to V. So from here you can see y versus x square, y versus x square graph is a parabola, right? So this also will be a parabola. Okay, that means this C, option C will be the correct answer in this case. Okay, because V is proportional to I square. This is the variation, so that's why C is the correct answer in this case. Okay, let us go to the next problem. This is again interesting because we will be able to apply Kirchhoff's law here. Okay, so see in this problem, let me just complete the problem. I have just given the figure. The question says a 10-volt battery, with internal resistance 1 ohm. A 10-volt battery with internal resistance 1 ohm and a 15 volt battery with internal resistance internal resistance 0.6 ohm are connected in parallel. As you see, are connected in parallel. Connected in parallel as shown in the figure. Connected in parallel to a voltmeter as shown in the figure. The reading of voltmeter will be, question is the reading of voltmeter. Voltmeter will be what? Okay, you have to find out the answer for that. Okay, so how do we solve this problem? Since there are two batteries, okay, they are connected in parallel with different internal resistance. So this is again 10. Okay, so this is 10 volt, this is this 15 volt. So we have to find out the voltage across this voltmeter. That means you have to find out the voltage across this. So this is actually combination of two batteries. Okay, so this is parallel combination of two battery with two internal resistances, nothing more than that. So in case of parallel resistance, okay, in case of parallel connection of battery, what we do, we have a formula for current. Okay, see, first of all we have to find out the current through the circuit or current through the voltmeter. That means current through the circuit. If we can get the current, then it is easy to find out. So what is the current here? See, we can just look, see, in this loop, what will be the current? We can just apply Kirchhoff's law here for this loop itself to find out the current. Let us now forget about this voltmeter. Okay, all right, so what you can do is the same current will be flowing through both the resistor, that is for sure. Okay, let us say I is the current which is flowing through the circuit. Now I have shown you the loop, that is the only circuit we are considering now. Okay, you can just go in this direction. Okay, so let us say I and this is 0.6. Okay, 0.6 I into 0.6. I is the current, let us say. I into 0.6 plus I into 1. So this is the voltage drop. And now on the right hand side, we will write the total EMF of the batteries. So in this case, this is positive 5 volt, and in this case, since we are going from positive to negative, so we'll take negative of 10. This will be 10 volt, negative 10 volt. Okay, so it is actually this much volt. Okay, so this is from Kirchhoff's law. Okay, so here we can find out this is 1.6 is equal to 5. So this will be 5 by 1.6. So it is some 50 by 16, 25 by 8. This is the ampere. This is the current. So 25 by I is 25 by 8 ampere. 25 by 8 ampere. All right. So I have got current. Now I have to find out the voltmeter reading. Okay, I have to find out the voltmeter reading. So voltmeter reading is the terminal potential difference across the cell. If I take this cell, then I'll just take this. Second cell. Okay, second cell is 15 volt. This is, we know, this is some 0.6 ohm, and here it is 25 by 8. Current is flowing through this. Okay, so what will be the voltage here? We know voltage is equal to EMF minus I into internal resistance R. Okay, so in this case, battery, so voltmeter reading will be E, that is the potential, like EMF of the battery, and this is 25 by 8 into R is 0.6. Okay, so this is, okay, so this is 15 minus 15 by 8. So this will be 8 point, no, let me just check. Oh no, it is, this is, so 24 my, this is, so this will be near around this much volt, 13.1 volt. So there is option B. Okay, so this is how we can solve this problem. Okay, we'll go to the next problem. So this electricity, current and electricity, mostly there will be Kirchhoff's law related problem, or this drift velocity, voltage, like drift velocity will be given. You have to find out the resistance, current density, electric current, etc. So these are kind of problems you will be encountering here. So the previous two problems both were actually from 2015 JEE main JEE Main 2015. Okay, Main 2015. This problem also was from there. Now we'll move on to other problem. So this is from again from JEE Main 2015. It is JEE Main 2015. 2015. Okay. What is the problem? The problem is saying that the electric network shown in the figure, no current flows through R. So in the electric network, so in this network, when no current, when no current when no current flows through four resistance, through 4 ohm resistance, sorry, this is resistor, we should write 4 ohm resistor in the arm EB. The potential difference between AD, the potential difference between AD A and D will be so options are so the options are here given as 6 volt, option B is 3 volt, option C is 5 volt, and option D says 4 volt. Okay, so this is the question. So in the electric network shown in the figure, no current, when no current flows through resistor 4 ohm in the arm EB, then what will be the potential difference between A and D? So this is the question. Okay, let us solve this. So how to solve this problem? See, we'll just take one thing. Let us consider Okay, so let me just take this figure to the other page. Okay, so let me tell you here, if we consider VD to be 0, then what about this VE, because they are just connected by this wire. So VD and V, like this E and D, these points are actually the same, right? And also when the current is not flowing through this, so these 2 points are obviously the same. This is actually lead current conducting wire. So E and D are obviously the same point. Okay, so then VE will be obviously 0. Now, as no current is flowing through the resistor 4 ohm, what we can say, see, no current is flowing through this. This means this VB, if I say the potential VB here, if no current passes through no current passes through 4 ohm, then we can say this point has opposite potential to this arm, right? This particular uh, so this VB will be then minus 4 volt. Okay, minus 4 volt. So therefore VA will be how much? If this is VB minus 4, so it will be 9 minus 4, then it is actually having 5 volt VA. So then what is the potential difference between A and D? The potential difference between A and D, we had already taken VD to be 0, 0. So VAD will be VA minus VD, that means 5 volt. Okay, so this is the answer. If no current flows through the resistor capital R, then VB is equal to minus 4 volt. Okay, and obviously this we had just taken VD is equal to 0, then we get VE is equal to also 0. Okay, so VE is equal to 0. So this is how you have to solve this problem. Okay, we'll move on to the next problem. So this is again a very nice problem. Okay, this point is not visible. I can tell you what it is there. I'll tell you there. So the question is, the supply voltage to a room is 120 volt supply voltage. The resistance of the lead is 6 ohm. Okay. A 60 watt. So this is power of a bulb. A 60-watt bulb is already switched on. What is the decrease of voltage across the bulb? When? What is the decrease of voltage across the bulb when 240-watt heater is used on the parallel to the bulb? That means, you have already a bulb. Okay, it is on already. Now you are bringing an electric heater. Okay, these are heating coil, say. Okay, you are bringing an electric heater and connecting in parallel. That has wattage of some this, and this has 60 watt. So you have to find out what will be the decrease. What is the decrease of voltage across the bulb? Okay, the main is this much. So look here, this both has actually their own resistances, right? What you can get, so this is P, we know P is equal to VI, or we can write V square by R, because I is not known, so V square by R. So we can find out R bulb is V square by P. Okay, so V square is 120 into 120 divided by 60. So 2, you have got here 240 ohm. What about electric heater? This has resistance, electric heater, say heater HRH. So this is also 120 into 120 divided by 240. Okay, this will be 60 ohm. Okay, 60 ohm. Now you have to find out what is the voltage drop, sorry, decrease in the voltage, So if I get the resistances, what we can do with that? We can so these are parallel to each other, right? Resistance and bulb, they are actually parallel to each other. Okay, so the question is, the lead wire, there were lead wire. Okay, there were lead wire as well. I'll just go to the next page and write down the complete circuit now in terms of symbol. I have This is RB, R heater. Okay, these are parallel to each other, and along with this you have 6 ohm. So this is actually 240 ohm we have seen, and this has 60 ohm, and this is connected to 120 volt. This is the question now. So what will be the voltage now? We can find out the equivalent resistance for this to be multiplication by addition. So this will give you, let this be here, this is 300. So this is 48 ohm. So I have got equivalent resistance for this as 48 ohm. Now I have this this is 6 ohm, this is 48 ohm, and this is 120 volt. So what is the current through the circuit? That we have to find out. So current will be 120 divided by sum of this two, 54. Okay, so it will be 60 by, okay, so let us, okay, so so this is 620 and 69 here. So 20 by 9. This is the current. Okay. So 20 by 9 is the current. So what will be the voltage then? So what will be the voltage? So voltage will be I into R across the bulb. So 240 into this. This is the bulb when it was connected to, so when parallel connection was given to this. Okay. So this, if you calculate neatly, approximately it will give you this much voltage. I'll just erase this part. I have found out when the electric heater was connected in parallel, but when it was not connected, that time what was that voltage across the bulb? You look, we have found out this is the bulb. So this has 240. So you know the current will be 246. Okay. So the voltage across this 240 will be 240 into, so this was, suppose this is 246. Okay. All right. So if you do the calculation part, it will come around 117073 volt. Okay. Now if you take the difference, then you'll get decrease in that. So we'll take the difference. So around 10.10 0.04. Anyway, let us see the options. 10.4. Okay, 10.04. It it should come 10.04. Oh, I have. Okay, so here this is the option which is coming near to this, so we can get answer as this one. Okay, so we'll stop it here for today. Next day we'll take up some more problems on this chapter, because this is also a tricky chapter, because Kirchhoff's law sometimes gives you trouble to solve if you are not thorough with the concept. Okay, so thank you for your patience. Bye for today.